is if I zoom out a little bit, you'll see there's lot of information here, which is information. Some of this information is for your reference only. Okay, some of this information is very advanced, and it's only for your reference. It's not to confuse you, not to basically intimidate you if you're a beginner, not to confuse you. So this is why just go with me step by step. We'll go step by step. We'll build up on our knowledge a little bit, and then I'll share the board with you, which you'll use for reference later on. And the access to this board will always be there with you. If you've attended any of my previous sessions, you know that the board always stays with you, so that won't be a problem for you. And to get started, this is the company that I run. So we build Web3 products. We're a Web3 product development lab. We are a very small company. We build Web3 or let's say blockchain-related products for our clients. And here are the technologies that we use. We use Hyperledger Fabric. We use Solidity, Cosmos SDK, Ripple, and many more. So I am myself a Golang and Rust developer. If you have been following me on YouTube, you already know that. You already have seen my Web3 videos probably. And apart from Web3, we also work with SaaS products. So we've built our own two SaaS products. One is Dominate AI, the other is Remote Teams. This one's still in extended beta. It's not released yet. All right, so you can connect with me on LinkedIn. Let me share with you my LinkedIn link. So I've shared with you my LinkedIn link, and you can also follow me on YouTube because that's where I share most of my content. In case you want to keep learning later on. So Bishop is saying he works on Hyperledger Fabric. Awesome, Bishop. Same here. I work on Fabric and Firefly. All right. So guys, again, just a clarification. This session is only for engineers, people who want to understand system design. Okay, and this session is not it's not going to be very simple. It's going to have a lot of information. And usually when we work with stock trading platforms, which are basically real-time systems, and we'll be talking about real-time systems, we'll be talking about distributed systems a lot in this session. So whenever we work with real-time systems, these are usually the most difficult problems that anybody can throw at you in a system design interview. Okay, so if you have worked on a real-time problem or an event-driven architecture problem in your system design round, then you don't really have to prepare more than that, because this is like, if you play a game, you have the final boss. This is almost the final boss in a system design problem round. Okay, so who is today's session for? So let's talk about that. So today's session, let me zoom in a little bit more. So who is today's session for? Today's session is for people who already have a little bit of basic knowledge about system design, who are engineers who want to apply for more senior back-end engineering roles. It's strictly and specifically for that target audience. Those are the only people who should be attending this session. Engineers who already have a basic system design knowledge and who are appearing for interviews, who want to follow the architect route, want to become a tech architect or eventually a CTO, and or you want to be a backend engineer or senior backend engineer, those kind of things basically. So almost all Mang companies, Fang, which is Fang earlier, now it's Mang. All Mang companies, they focus very heavily on system design, and the reason is that system design is kind of a macro level thinking. So a lot of these companies, the bigger companies or the super solid engineering companies, they want engineers who can think from a 10,000 feet perspective or from a planning perspective, and not just from an execution perspective. So if you're just a cog in the wheel, if you're just writing code for a very small functionality, you don't have a lot of understanding on what's happening in the complete system, right, from systems perspective. But as you go up in your career, you become more and more senior as a developer or as an engineer. You need to be able to understand how the entire system works. You're not just focused on one small functionality, okay? And this is why system design is important. So what is system design? System design is basically something that you do, like a kind of planning that you do before you start thinking about your cloud architecture or your software architecture, your project structure. So this, usually if you go to a company, if you go to a good engineering firm, this is the process that is usually followed. You get a system design. So everybody in the team, they kind of come in and they focus on planning on system design. Then they work on the cloud architecture, in the sense what all cloud technologies you will be using for that system design. Then you think about the software architecture. then you think about your project structure, and then at the end you think about code. So beginners, they start coding directly from day one, from as soon as they get a project, they start coding. But pros, or people who are really senior, they think about systems, they think about cloud architecture, think about software architecture, think about project structure. Now these could be all different people, right? Just one guy is not doing it. Maybe you're just doing system design, maybe you're just doing cloud architecture, depending on what kind of role that you have. But system design is something that already almost always everybody needs to understand really well. So it doesn't matter if you're becoming a solution architect, software architect, cloud architect, it doesn't matter. You have to have a good information about system design. And obviously, if you're a CTO, the higher you go up in your technical career ladder, the more system design you have to understand. Okay, and coding is happening at the end. So a bad way or an anti-pattern or a bad practice is to start coding directly, like I said. But a good practice is to think about system design, then cloud architecture, software architecture, project structure, and code. Okay, and if you are into system design, right, you want to portray your problem-solving skills in a system design interview. You want to show that you can think of from a macro perspective. Macro basically means from a wholesome perspective. Like you have the complete picture. You can see the complete picture. You're not just somebody focused on just building one small functionality like a like button or a comment button, right? You understand the entire product from end to end, how it works. That is called systems thinking. And how that entire product is going to scale up. That's called systems thinking, right? So it's a very, very important topic. Extremely important if you want to go up in your career. Extremely important if you want to apply to bigger and more serious companies. And it's going to be even more important with Web3, because Web3 is highly complex, as all of us know that. So it's going to be becoming very, very important in the future as well. Okay. So like I said, senior roles, the senior the role, the more understanding of system design you have. Okay. And this problem that we are solving today, which is system design for stock trading platforms, this is kind of an advanced problem for system design, right? So this is like the final boss, almost the final boss that you see as system design problem. Now let me see what's happening in the chat and all of you are able to see it. Problems. All right, so I think chat seems okay. All right. Okay, so coming back to the board. Okay, so this was the intro. So we've all understood what is system design and why we want to learn system design. We've understood that. We've understood what this course is for, who today's session is for, right? The session is only for engineers who want to apply to senior positions, who want to get serious about engineering and who want to apply to bigger companies, and they want to basically learn how entire systems work. All right. Now, there are a few basic terms that you should be knowing. If you have come into the session, you should be knowing these terms. But, it's possible that some of you don't know these terms. So that's why I just wanted to go over these quickly in like the first 5 minutes quickly before we head any further. Okay, because if you don't know these terms, I know, my session is not supposed to be a basic system design session. Okay, it's always supposed to be an advanced level session, but sometimes even beginners, they do end up coming to the session. So that's why I don't want to leave anybody out. So if you're an experienced developer or engineer, please, for the next 5-10 minutes, you can zone out if you don't want to listen to this. This is for beginners only. So I'm just doing a quick basics, brush up in the next 5 minutes before we go into any further into the more advanced aspects of system design and begin talking about more advanced things. So load balancing is an important concept with system design. So if there are multiple servers, you want to understand which server is free right now, which has less traffic. Which server should you direct the traffic to? That's basically the job of a load balancer, right? So the way I'm explaining to you these terms is going to be very simple language that how I would explain to a 5-year-old. That's how I'm explaining to you. I'm not going to use very highly technical terms, right? Because if somebody who's a beginner who's listening to this, I don't want them to be left out. So load balancer think of it as as a technology. The sole job of this technology is to understand which server is free right now, doesn't have a lot of traffic, so it will basically direct traffic to that server. Caching. So your front-end server, you don't want your front-end server to always keep making a lot of requests to the back-end server, right? So you might want to just store some information at the front-end side itself. You can do that with caching. Again, for back-end servers, you don't want to keep making requests from back-end to database all the time because reads can be expensive sometimes. So you want to just store some information like cache information that gets used up very often. you would want to store it in the cache. So cache is basically like a in-memory temporary storage. That's cache. So I hope everybody has understood these two terms. Like I said, for senior guys, you can zone out for the next 5 minutes, because I'm just going over these terms quickly so that beginners can understand. Because we can't go any further if we don't know these basic terms, right? So horizontal and vertical scaling. Now, if you have some servers, if you have one server, let's say, and you add one more server at the side, that's basically horizontal scaling. You can add more servers together. So that's basically horizontal scaling. And then if you have that server, one server, and then you basically add more resources to it, in the sense you add more RAM to it, more computing power to it, that's vertical scaling. Horizontal is usually more effective. We'll see why in a while. Okay. Proxies, we want to have some security and stability, and also a little bit of scalability. So we introduced something called as proxies. You must have heard about forward and reverse proxy. They handle requests, they filter requests, and they even transform requests. Okay. So that basically help you handle a lot more requests than you would be able to handle. Then comes CAP theorem. This is one of the most important concepts in system design. CAP theorem is basically consistency, availability, and partition tolerance. Okay. Now, here it says pick two. So I got this diagram from the internet. It says pick two. Basically, you can either pick CP, which is consistency and partition tolerance, or you can pick availability and partition tolerance, or you can pick consistency and availability. So what are these terms? Consistency basically means, so let's talk about availability first. So if you are able to, so I'll explain it in very, very basic terms, right? So you'll be able to find thousands of videos on YouTube for these. Look it up. If you don't know what CAP is, look it up later on. I'm just giving you a very, 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 very basic explanation. So then think about a database, two databases, or just one database. If you make a read and write request to it and it's able to respond properly in a very reasonable deadline, then that's basically available. So the database is highly available. All right. Consistency. There are two databases. If you make a write request to both of them, and then you make a read request, and both of them basically have the latest write information, WRITE, latest written information, they have it. That's consistent. Both of the databases are consistent with each other. They're interacting, and they have both the written information. So it doesn't matter you wrote in both the databases, or you wrote in just one database and it was communicated with the other database, but they're both in sync all the time, and they both, whenever you query them, they always have the latest written information. That's consistency. Partition. So if the sync between these two databases breaks down, and they're still when you make a request to them, they're both consistent in the sense they're sending you the recent written information. That basically says that the databases are partition tolerant. So now the problem with CAP theorem, or just like we have in blockchain, we have the scalability trilemma, right? Many of you must have heard about it. In Web3, we have the scalability trilemma. In Web2, we have the CAP theorem, where you can't have all three together. You can either have CP, you can either have CA, or you can either have A, right? And real-time systems, like in our case, which is stock trading system, it's going to have CA mostly CA, but we can do a lot of AB also. Now, if we were constrained by just saying that we have a particular type of monolith architecture, if we had just monolith architecture, we would have to pick CA only. But because we are going to pick later on, we're going to pick microservices, and the reason that we'll be picking microservices later on as an architecture decision is because we want to be able to isolate these services and then have pick different priorities for every single microservice. We can do that. So microservices allow us to pick different priority between CAP for every single microservice. So most of the order-related microservices you want to have the CA category, you want to have consistency and availability, right? And some user-related data you want to have in the CP category. You want it to be consistent, you want it to be partition tolerant. And a lot of the front-end related data, like the ticker prices and all of those things, you want it to be AB, since you want it to be available and you want it to have partition tolerance. Okay. So we'll choose. Like I said, I'll just repeat again. This is CAP theorem. We can either choose only two of these at any point of time. We can't have all three. That's the just like in blockchain, you have the scalability trilemma problem. Here we have CAP. You can't have all three, so you just have to pick two. Now, choosing microservices later on will give us the ability to choose different categories for different microservices, and that's the beauty of microservices. Okay. All right. So we'll talk about microservices more. So in case you're new, don't worry. Databases. So somebody was asking me, are we going to be talking about databases? Yes, we'll be talking about databases. Databases, from a system design perspective, from a basic system design perspective, all you need to know are three things: replication, indexing, and chart. And since you will be getting access to this board after the session, you can obviously look it up. It's always there for your reference. I've written the definitions here. Okay, replication is you can create replicas of the database very easily. But I've also written that communication and sync between those databases can be tricky. Indexing, a lot of you already know indexing. Basically, you add indexes on particular fields to reduce search times. They basically store the data in a particular way. Okay. And sharding divides tables and and stores them across multiple databases. That's a way to scale up, right? Sharding is the way to scale up. There are two ways: horizontal and vertical. And you can obviously read about that in case you're starting out. So these are all the terms from a basic system design perspective. These are most of the terms that you need to know. Right. Now there are some advanced, I won't say advanced, but a little more if you want to know, is what an index looks like. You have a search key and you have some data reference, right? That's what an index looks like in a database. Basically, you're sorting the information. Let's say you want to get some data by age of in the database, age of the users. You want to fetch that information. So you'd want to put an index on the data on that field age, so it'll store the information in a way that it's very easy to search. You can sort it out in a particular way. Right? This is what an index looks like. It has these different definitions. So with index, you get access types, access time, session time, space overhead. The most important one being space overhead. With scalability, this problem comes in because your indexes require extra space, and a lot of system design engineers they forget that your indexes are also going to need extra space, and this ends up becoming a bottleneck later on at a very large scale. So this one is the last one is the most important. Other ones, if you don't know, that's okay. But from an interview perspective, this could be an important question for you. What is the space overhead in indexing of a database? Okay. There are two more things that these two things are completely optional, and you don't have to read about them if you don't want to. One is sequential file organization, which is how index works, and hash file organization. So like I said, there are two ways the index can organize some data. Like let's say you want to access some data by name or age, you can store that data in sequential file organization or hash file organization, depending on how you want to do it. And there are then different types of these as well. There's dense, sparse, clustered, secondary, and vertical. Right. I've kept them here, and at the end of the session, I'll also put definitions for these out here, so that you can, I'll put these definitions here so that you can read about these later on. I'll do that for you. Don't worry. So these are the basics. Now this were like the very basics before we can go any further. That's why I wanted to cover this. So I'm sorry if there are senior engineers here that they're feeling that I didn't have to cover these. So I'm sorry for that. Sorry for wasting those 5-10 minutes. But I wanted everybody to be on the same page with these terms, right? So don't want people to get confused later on when we actually get started. So this is the step 3 now. Step 3 is when we actually get started. And I'll just zoom in a minute. Let me check what's happening in the chat if everybody's able to hear properly. Okay, so yeah, so I think everybody liked. So they're saying great ideas. Thanks for explaining. Thanks. All right. So people, I think liked what I explained. All right. So I'm getting a lot of yes also. All right. Now let's talk about trading flows. Okay. So as all of you know, we are designing the system for a stock trading platform. Okay. The reference that I've used here is Robinhood. So there's an app called Robinhood. That's the one that I'm using for reference. And most of the things that we're covering here are from a perspective of Robinhood. All right. So I just wanted it to be clear. It's kind of like Zerodha, but Robinhood has a lot more things. You can do a lot more. Okay. Now the process, if you make an account at Robinhood, this is what it looks like. So I highly recommend using this app called Robinhood. It's really cool. And this is what the process looks like. You sign up. Now, by the way, guys, I'm showing this to you, this user flow to you, because before you start designing any system, you want to have a basic user flow mapped out. And the reason for that is that you will understand the components or the modules or the services that you would want to use in your system based on this user flow. Okay, so this is a very, 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 very important step. Do not skip this step. I sometimes skip this step in my sessions because I have so much information to give you, like load you with all these terms and information, that I skip this step and I show you the system design directly. But then I realized that a lot of people thought that they could skip this step, but you can't. That's why I've started now including these steps in my presentations, because I don't want you guys to skip it. Earlier, I used to just say that you have to design this user flow. Now I actually design this user flow and show you inside the session itself, that because I don't want you guys to get confused or think that you can miss this step or skip this step. You can't skip this step, guys, because this will show that you have a level of depth to your thinking, right? So when you walk into a system design interview, you want to show your knowledge, you want to show your depth of thinking, you want to show your problem solving ability, right? So the second thing, which is depth of thinking, you show by demonstrating how deep you can think in the user flow, right? So at least a simple user flow needs to be there. So if you have like a limit of 45 minutes for your system design, you want to have at least a basic flow mapped out, right? So you can sign up, you can send referrals, and Robinhood you can send referrals. Okay, you can have reset and recovery of your passwords. You'll have to verify yourself on your email and phone number as well. You'll have to upload some documents depending on which country you're in. You'll have to upload some documents. This, by the way, happens with Coinbase also. This happens with Mazirex if you try buying in crypto. This happens, in all of the platforms. They do KYC checks and all of that, right? So you have to upload your documents, and many of these documents they also have an element of manual approvals from the Robinhood side. So they do a lot of manual approvals now, and then there are bank integrations, and you have your wallets. Then you have your dashboard. From dashboard, you see two things mostly. So you see so many things on a dashboard in Robinhood, but I've just considered the two most important things, right? One is you see your transaction history, what all you've been doing in the past, and then you see the ticker prices of the most important, stock prices that are going on right now. Ticker prices basically means like you'll see Facebook stock, you'll see Apple stock, Tesla, TSLA, those kind of things. Those are basically ticker prices, and you'll see what exactly is the price right now. So depending on what currency you select, you'll see it in dollars or rupees or whatever. On Robinhood, mostly you'll see it in dollars, and then you can say take some actions. After looking at ticker prices, you can actually click on any of those stocks, and then you can buy or sell those stocks that you want to, and then you can do some data operations also. Right, so data operation in the sense the whole point, as in the reason why one trading platform is better than the other trading platform. They won't tell you this, but this is the reason why people pick one trading platform over another, is just because of the data visualizations it provides you. So the better analytics engine that you use, better data that you're able to show, the higher chances of that platform getting adopted. So Robinhood gives you a lot of data visualizations. That's why Robinhood is very popular. People use it a lot. Similarly with FTX, if you guys use buy crypto, if you use FTX and Binance, so they use a lot of nice charts and graphs, right? So people, that's why they like people use it a lot. Candlesticks and all those graphs you get. Now you can see the best performing stocks in the past. You can see the top new stocks, the highest performing stocks, and then you can do a lot of searching, filtering, and sorting. So these are three main operations into one stock, and there are so many more operations, but right, when I say best performing stocks, you get those charts. You can compare one stock with another. You can see its performance over time. You can select like 1 year, 3 year, 5 year, like all those UI elements you can do basically. All of those are operations, but very simplistically I just said you can do three things, but we both know that there are like hundreds of things you can do there, but I'm just very simplistically I'm saying that there are three things, right? And this is your visible trading flow. In the sense, if anybody who's trading on a platform like Robinhood or FTX or Binance or something like that, these will be the visible trading flows. So by visible and invisible, I mean that a lot of things that the users interact with and see in the app are visible trading flows. But if you just consider these, you won't come across as a very deep thinker or a very experienced engineer, right? Because experienced engineers, they know about invisible flows as well. So there are some flows or some components or some aspects that are invisible that the user does not interact with, that are happening behind the scenes. You always want to consider the invisible flows or the invisible services and components and modules. Okay. So what does that mean? So basically, whenever these buy and sell orders are happening, right? So we know that buy and sell orders are happening by the bulk. Like you have at any given point of time, you have thousands of buy and sell orders filtering through the system. To be able to handle that, you would want to use queues. Now, if somebody who doesn't know queues, basically queues are technologies that help you. I'll give you in very basic terms, and later on we'll understand more about queues. But right now, just very basically, queue is something that helps you to order out your events or order out your orders. In this case, these are orders, right? Or you can also call them as events. If you want to buy something or sell something, that's an event that's going through this queue, and you want to order it out. You want to keep them in order, and queues basically help you to maintain it in a proper way. Otherwise, if you just send all of this, imagine in just a quick REST API. You just called an API and sent these thousands of buy orders in one go. It will fail. All of this system will fail. Right? That's why you use queues, because you want to maintain like a order. Now it's the queue's responsibility to maintain that whole flow of all these buy and sell orders that are happening. Right? So you're using queue for buying. You're using queue for selling. Then these are, by the way, the invisible flows. In the sense, the user does not care what's happening at the back end. We are basically using a queue to store the buy and sell orders, but the user does not care, right? So for the user, it's invisible. This is invisible. And then you have pricing algorithms. You have recommendation algorithms. All of these are feeding off from the buying and selling information. Okay, and I've mentioned here. So after I give this board to you after the session, I have written all the text in the right places so that you just have to zoom in and you just have to read the text, right? So in that ways you won't have to, you won't forget what I talked about when I was showing you this slide, because there's actually text written here, right, to explain all of these things. Then the queue is basically taking to a service that executes these trades, like either buy trade or sell trade order. You want to execute those trades, so the queue is responsible for taking that to this service. And after you perform these trades, you want to notify the service that, hey, this user had purchased this stock, or hey, this user had sold this stock. So all the other services want to get updated that these emails, if emails need to be sent out, if notifications need to be sent out, all of those. Then you also want to store this information. So all of the information, like let's say buying and selling information, you want to store it. Why do you want to store it? Because you want to show historical order information, right? And you want to inform external services. By external services, I mean all the other APIs. So usually our systems, they write or they send information to other systems using, let's say, webhooks, right? So whenever you want to communicate with an external system, let's say somebody else's API, some other system waiting for notifications or from data from our system, we usually publish this information on something called as a webhook. Webhook is like, instead of calling an API, you push data to a webhook, right? So you push the information so that that other system that was waiting for the information, that receives the information, and now it can perform some operation based on that information. So you can inform external services, you can push data on their particular webhooks. That's how you do it. And most importantly, you get historical order information. Okay, so very important. I hope you've understood what webhooks do, what they are, in a very simplistic way, right? So this was a majority invisible flow that's happening, right? Now I also want to show you that there are these special APIs that you get with New York Stock Exchange, Shanghai Stock Exchange, NASDAQ, Bombay Stock Exchange, right? National Stock Exchange, London Stock Exchange. You get these special APIs, and you can also buy historical data. Now the APIs that you get from here are they're extremely fast APIs. You don't get slow. Obviously, you can't work with slow APIs here. You get very fast APIs. You can also expose your webhooks to these guys. This is how the interaction and integration takes place, right? To integrate with any of these, you also have to be a really big company. You have to produce a lot of things. Process is really long and all that. But most important thing being that you get APIs from these, right? NASDAQ, New York Stock Exchange, all of these, and you get historical data. You can buy historical data. You can buy bulk of historical data, and this you will only buy because let's say you're a new platform. You just open up your own app today, like Robinhood. Then you would want to buy a lot of historical data to show nice graphs and charts and all of that. to show historically how the data did. But if you have been operating your app or your system, stock exchange for quite some time now, stock trading platform for quite some time, you wouldn't have a lot of need of buying historical data from these platforms. You would be storing and maintaining your own archive of information. And then we have some systems that aggregate data coming in from APIs. They clean up and organize that information. They transform. Now, transform basically means, let's say something came in XML, you want it in JSON. Something came in CSV format, you want it in JSON. This process is called as transformation. This is a very important process. Happens all throughout big data platforms. And at every point, like in data streams and queues and all of these systems, transformation is already happening. And usually the systems that do a lot of transformation are called as ETLs, extract, transform, and load systems. We'll look at them in detail later on. But those are the systems basically responsible for transformation of data, right? So I hope you understand that you would get a lot of XML information from one API. You'll get some HTML information. You'll get some CSV information. You want that to be available in a particular format for your front end to be able to render that information in JSON. So you'd want JSON information. All of that is happening at a bulk, huge scale. Sometimes it's happening in real time, and we're seeing that JSON information being shown into charts, like whenever you use D3.js or some charting library like that, charts.js, high charts, whatever you want to use. Those charts, they require JSON, that. And that transformation is happening with ETLs. And then we've already seen what is indexing. Right? So storing indexing also happens on the data coming in from the APIs, right? Now, a lot of data is historical data, but some of it is real-time data that's happening in real time, and we want to do all of this in real time sometimes. Okay. Now, there's one more thing, which is stock data service. So we'll have something called a stock data service, which we are considering to be like a central, resource in our system, which is going to have all the information of all the stocks. So every platform, like let's say today we think of developing our own platform for stock trading, we would have to maintain, or we'll have to take a decision on which stocks we'll be trading or we'll be showing on our system, right? We can't possibly list all the stocks on the planet, right? We'll have to make like a list of 10,000, 15,000 stocks that will be traded on our platform, which we'll be showing the information for. And depending on that, we'll be integrating with these guys, depending on that, right? Depending on the stocks that we'll be showing in our platform. And so all of this information usually resides in a central place. It's called as a stock data service. So we'll have multiple services. We'll have a stock data service which is going to store all this information. So where does it get information from? It gets now there are separate, even after you integrate with these guys, right? You have some separate APIs for getting this information. So commodities information, not necessarily you'll be able to get from these guys. Commodities information, forex information, your bonds, derivatives, and mutual funds and crypto. For all of this, you'll require separate type of APIs. So that information you can get from external sources, you can get from different APIs, you can get from webhooks, like I mentioned. And all of this information is coming to our stock data service, which stores the final list of the stocks that we will be trading on our platform. Then two operations happen on our stock data. One is currency conversions, because every user wants to be able to view the stock information in multiple currencies. You'd want to view it in yens, in pounds, in euros, in dollars, in rupees, depending on which country you're from. So even for people in India, they sometimes prefer to trade in dollars or dirhams, right? Depending on which currency you find more stable. People buy using rupees, they buy dollars and dirhams in all these currencies, right? So a lot of currency conversions are happening. And these currency conversions sometimes happen, actually, I won't say sometimes. These days, the best practice is that mostly they'll happen through external APIs. So you always, you're maintaining like a cache. Let me write it here actually, so that you guys won't forget it. So you maintain like a cache of currencies information. And this is changing every 1 second. And depending on how accurate you want your system to be, it can change like in 15 seconds or 20 seconds or 30 seconds. But ideally, you want it to be changing every 1 second. And every 1 second, you'll have data flowing in through different APIs. Okay. And now, why do you want to cache this information? right? So I have explained to you what is cache. Cache is like a temporary storage, memory storage. But why would you want to store information? So caching, when you're working with an external API like a currency conversion API, caching helps you save money. You don't want to, the more number of API calls you make to an external system, the more money you pay, right? So all of these systems and all these terms we are learning, right? They're just not just technical. They're actually to save money. All of these things we're doing to save money, right? So our system becomes more efficient and more cost efficient actually. So if you want to make less API calls, you ideally want to store that information in a cache, because in that 1 second, if thousands of users quickly access that same information, you don't want to have 1,000 API calls. You want to have just one API call that calls every 1 second. So he stores the cache with the same value, like a hash map, and all of your users want to be reading from the cache. They shouldn't be calling APIs on your behalf. Okay, this is a great pattern. This is like a good read-through cache pattern, and you might want to talk about this in your interview. You'll be able to sound smart. That hey, you can save money using cache when you work with external systems. This makes you sound smart, basically. And the more from a business perspective you are able to look at things, the higher you get rated as an engineer as well. And then you have your time zones information, your context, and all of that. And those basically go into showing your ticket prices. This is what the user sees, right? So user sees this ticket prices on his screen, but there's so much happening in the background, right? You can see all this invisible flow. All of this is happening in the background. Why is it happening? Just for this thing. You're going through all of this. Okay. All right. So now let me quickly check the chat if all of you are doing okay. Okay, so Suraj has said, what is ticker price? So Suraj, ticker price is basically, you see that, right? Facebook and Intel and Apple, all those prices and those names, those are basically ticker prices. So Ashish, share this flowchart, please. Ashish, in some time I'll be sharing this flowchart. I want to just cover the most important things because you guys will get a little confused. Okay, a lot of chat has happened in just 1 second. I'm not able to read so many. Right. So yeah, Vignesh is saying even for cash we have to spend money. Yes, Vignesh, you have to spend money for the cash, but that's very low in comparison to the API calls that you make. API calls, the external system is charging money. Cash, you're just storing it. So Dhruv is saying, how do we update the cache every 1 second? Dhruv, there are multiple patterns to update the cache every second. You can do long polling. You can make API calls and then store it there in the cache. You can have data stream directly pushing data into your cache. A lot of different patterns are there. A lot of different ways to do it are there. Okay. So a lot of questions are coming in. So guys, put the question in the questions tab if possible. Okay, not in the chat because it's very difficult for me to go through so many chats. And questions I'll pick up again after 15 minutes. Okay. All right. So coming back. Now this is another, so I hope you've noted down that first we design, whenever we start with system design, we design the visible flows that the user will see. Okay, write it down somewhere, write it down guys. Write down these notes. You have visible trading flows, and then you have invisible flows, right? You have what's happening behind the scene. You want to basically make a flow of both of these things in your system design. Depending on how much time you have. So some companies, they'll give you more than 1 hour for system design. Some companies will give you just 45 minutes. Depending on how much time you have, you'd want to do this. But even if you don't like officially show it to your interviewer, you might want to do it on pen and paper quickly, just to see what's happening behind the scene, just to like get your thoughts together. Okay, so if you have less time, you're on a time crunch. You don't have to draw this in front of your interviewer. You can just do it on pen and paper quickly, just pen and paper exercise, and then actual system design you can draw in front of your interviewer. But if you have time, if you have more than 1 hour, then feel free to actually design these two visible and invisible flows. Okay. Now comes an important part. These are estimations. Okay, these are estimations, and this is also called as back of the envelope calculations. So why do you do these calculations? Why do you do these estimations? Because you want to know for what scale are you designing the system for. And these calculations will help you to guide your decision for your technical architecture. Okay. So usually what happens with the system design problem is that you have to decide on a technical architecture at the end. So technical architecture is like macro services, you have monolith, you have service oriented, you have space based, you have microservices, right? So your calculations basically help you decide on what is the right architecture for you. Okay. And not only your calculations, but also we'll look at some considerations. So those considerations will also help us think of the right architecture for this. So now let's look at estimations. So per geography, when I say geography, I mean per country. So like let's say in India, there are 50 million users, in US, there could be 50 million users. So so I'm assuming that per geography, like India or maybe in Asia, however you want to categorize it, we'll have 50 million users. And now you don't have to say per geography also, right? If you can say total users on the entire platform, you could say 50 million. But here I've just to add a little bit more dimension to the whole thing, I've said per geography, because in my case I'm going to have geography-wise replication also of the entire architecture of the entire infrastructure. I'm going to have that. So that's completely optional, right? So what I mean, maybe you got confused with what I'm saying. What I'm trying to say here is that when you go to Facebook, you're not hitting the servers of Facebook in US. You're actually visiting Facebook India. Similarly, Uber has its complete infrastructure in India also. So similarly, Robinhood and all these apps, they have a complete system in India. They have a complete system separately in the US. That's why I've said for geography, I'll have, in my case, I'll have replication of infra per geography. Okay. It's completely optional. You don't have to do it. It just makes the system design more complex. But I'm just showing you in complete complexity what all you need to consider. Okay. And how many monthly active users will you have? So in my case, I'm saying that out of these 50 million people who are my total users, at least 10 million will be monthly active. Daily active, out of these 10 million monthly active users basically means out of my total users, how many people end up using every single month. Okay? And daily users basically mean that out of these monthly active users, how many people actually use my system every day, every single day they log in. So there are people who log into Facebook every day. People log into Instagram every day, right? So those are daily active users. So from a stock trading platform, these are big numbers, right? So very few stock trading platforms are able to attract so much of traffic, but we are considering the biggest ones like Robinhood, so they have this kind of traffic. So that's why we consider this kind of traffic. Okay, and concurrent users at any given point of time, at every second, any given point of time, we'll have 200,000 concurrent, 2 lakh concurrent users. Concurrent basically means that they're all online at the same time. Okay, and average number of buy and sell orders per day per user. So I'm saying that any user who comes to a stock trading platform, he would either place in buy orders or sell orders. So there'll be, let's say, 20, at least 20 buy or sell orders in place. Okay, and so that means how many total buy or sell orders are there in the entire platform? Because I have 200,000 users, every user is giving out 20 buy or sell orders. That means 200,000 and 20. I'll have 4 million total buy and sell orders per day by all users. In one day, 4 million buy and sell orders. So why do you want to do this estimation? This is a very important step. You don't want to miss the estimation step. You want to show the interviewer, or even if you're designing for real world, right? You want to understand what scale are you expecting, what scale are you going for, right? You don't want to just leave from Pune to Bombay without knowing the distance between Pune and Bombay. Right? You want to know what's the distance, how much time it'll take to cover, and what is the right means that I should take a bus or a car, should I take a flight, depending on the distance. So that's what we're doing here. We want to understand the scale. Okay, and like I said, whenever you build a system for stock trading, you want to understand, you want to take a decision on how many stocks will you be listing and tracking. In our case, we'll be tracking and listing 10,000 stocks, and annually. So I've written here for archive service. So whenever this buying and selling is happening on your platform, you become susceptible to many security issues. You become susceptible to hacking. You become susceptible to legal issues, because people could say that, hey, I paid money, but I didn't get the stocks, or my money got detected, or my money disappeared. So all of these issues will happen when you do any buying or selling on your platform. Also, you have to pay GST, you have to pay many taxes, TDS, all those different things have to happen, right? So, how does that happen? That happens because you have to maintain something called as an archive. Archive is like, so with AWS, you get an archive database, but what archive database basically is it's a cold storage. It's a huge, humongous, big data storage where you're just pushing a big amount of data down. You're storing in your archive database. An archive database is going to have your years and years old information. So why do you want to store this? You want to store this, like I said, for auditing purposes, for let's say if you get legal trouble, those purposes. If somebody wants to actually see their past history of multiple years, you can do that. You want to create reports and send it to the government, you can do that, right? All of these different things will happen with your archive services. This is a very, very important and critical function in a system where you do any buying or selling. You want to have archiving. Okay. So many people have this question: why don't you just store data in a regular database? Why do you need a special archive database for for this old information? The reason is that the more data that you have, the more time it takes to query that information. So only the latest information you want to maintain in your current databases. All the old information, like more than 1 month old, you want to start pushing into your archives. Is that okay? I hope everybody gets it. So for our archive databases, to scale our archive database, you want to understand what's the size of the archive database that I want to have on the cloud. Okay. To be able to do that, I want to know what are my total buy and sell orders per year. Per year, since I have 4 million per day, I've just calculated here with all of you, 4 million buy and sell orders per day by all users into 250 days, because we all know that stock markets don't work on every day. They work only on 250 days in a year because there are multiple holidays and all of that stuff is happening. They don't work on the weekends, right? So 250 days is what we consider. So we're basically saying approximately 1 billion, right? In buying and selling orders per year annually are happening. And then you want to consider bandwidth. To consider bandwidth, you want to say what's the data per stock. So per stock, you get some information from, let's say, an external API or somewhere, you get some information per stock. Per stock means Apple or Tesla is a stock, right? So you get some information like what's the price, the kind of information that you get, like, I'll show it to you. It's like, basically it's like this. You'll get a JSON object like, what's the ticker name. Ticker name could be Tesla, and you could get the price. Price could be 20. Basically, that's sort of a JSON object you'll get, and you'll get what currency this price was in. So you'll say USD. And this is just a little bit of the information. There could be so much more information here, right? So much more information. And we are assuming that this information per stock is 2 KB, 2 kilobytes, 2 kilobyte information per stock. And what's the bandwidth required? So bandwidth, I have 2 KB, which is this info per stock. And I have 10,000 stocks listed. So I'll say 2 kilobytes into 10,000 is equal to 20 MBs. 20 MBs is the bandwidth I require. So per second, can you imagine per second 20 MBs of just stock information is flowing through my system. And so I have to account for that. Now, that was just a ticker service. Ticker service basically means you're showing information of the ticker prices of the stock prices. That is it. Just to show information, you want that much bandwidth. What about buying and selling? Buying and selling, you also need more information. So you'll say that, how do you find the bandwidth for buy-sell service? Now here I'm considering very, very, very moderate and very modest kind of bandwidths, right? They'll be much more, but I'm considering very moderate and modest ones. How do you find bandwidth? You'll say there are buy and sell orders per second into data buffer size. How do you get the buy and sell order per second? You'll say that you have buy and sell orders per day divided by number of seconds in a day multiplied by this data buffer size. So basically, buy and sell orders per second, they become equal to buy and sell orders per day divided by number of seconds in a day. So number of seconds in a day we know is 3600. And buy and sell orders per day we know is 4 million. So we'll have 4 million divided by 3600, which is a number of seconds. into data buffer size. Data buffer size 4 KB. Where did you get from? We get it from, okay, so we are assuming here that data buffer size for every buy or sell order is 4 KB, 4 kilobytes. So it will be basically 4 Mbps of bandwidth that we require. Okay. So we need 20 Mbps bandwidth for ticker service and 4 Mbps bandwidth for buy and sell service. Okay. So these were our calculations. Now, little bit of low-level system design. Low-level design. So somebody was asking me if this is only HLD or LLD is also there. There's, like I said, 99% is HLD. Just 1% I just included a little bit of LLD also. So for all of you who don't know what is HLD, LLD, HLD is high-level system design. LLD is low-level system design. They're both part of system design. Okay, and usually, usually if you're going for a very senior position, you will be only asked about HLD, like high-level system design. Right? You won't be asked many questions on HLD because LLD. Sorry, you won't be asked many questions on LLD because they would know that you'll be quite high up in the ladders, and there will be people under you will be worrying about the LLD. But anyways, we'll still talk about LLD here. Okay. So LLD, this is what when we say buy or sell, we have written it here as bid. We'll have int price, which will be an integer count. How many stocks do you want to buy or at what price? Bid type and stock ID. Basically, stock ID is that Tesla or Facebook or Amazon, what stock do you want to buy? And do you want to sell or buy? Basically, bid type, right? So this is what it looks like. Which I kind of drew here also for you guys. And price ticker. At what time? This is why I said that we'll have to have our what do you call it? Time. Times also want to check time epoch. We'll have price and we'll have stock ID. So this will be our price ticker for our ticker service price ticker, and this will be our buy or sell for our buy or sell service. Okay. So this is what low-level design looks like. We'll be actually designing the actual schema of every database. that's what low-level design is. All right. So we have covered quite a lot of topics. Okay. Now, people who have just joined, let me just tell you that we went through the intro on what is system design. This board will be with you after the session. So we went through what is system design. We went through the basics, some basic terms that you want to know, like load balancing, caching, proxies, CAP theorem, all of those. Then we started doing the system design, right? So we started creating some visible flows, like let's say what the user will go through his complete journey on a stock trading platform. Then what happens in the background, some invisible flows, we design those as well, and how it's happening. The user doesn't care about it, but we do. As engineers, we have to think about all these things. Then we did some estimations and calibrations, right? So these three things were important, these three steps. Visible flows, invisible flows, and estimations. We did that. Now we have two things we can do, all right? We can learn about real-time systems and event-driven systems and distributed systems, or we can go directly into domain-specific design. So let me first check out the chat. Okay. So, guys, would you want to learn about real-time systems a little bit more, just like what I have here? Do you want to learn about that, or do you want to directly start system design? Okay. So many people, yes. Many people are saying yes, they want to learn. All right, awesome. Okay, so before we start with real-time system design, real-time systems, let me take a couple of questions. Questions tab is kind of full right now. It has more than 100 questions. Okay, so Shubham is saying, is distributed tracing useful? Yes, Shubham, distributed tracing is quite useful because we'll have a distributed system now. So to be able to find out the logs, to be able to see the logs of this entire system, we want to have to use distributed tracing. Okay. Rahul Namdev, as an SDE1, is this going to be beneficial? So Rahul, the faster or the sooner that you can start learning about system design, the more it's going to help you later on. But yeah, for more senior roles, this is kind of more beneficial. System design is more beneficial. Okay, so Moni Sankar is saying, please also talk about tech stacks used for systems. Yes, Moni, we'll be talking about that after a while, but not in too much detail. So if you start talking about the technologies, then it kind of becomes like an architecture problem, not just a system design problem. For system design, you just want to talk about what you use. Like, let's say, would you use a queue? Would you use a stream? Would you use a load balancer? But you don't want to talk about which stream or which queue or which load balancer you use. That'll be an architect's problem, right? An architect would be thinking about, is Kafka better than Spark, or Flunk is better, Flume is better, Flink is better, whatever. Arca streams are better. That's the architect is kind of doing. All right. So Manjunath is saying, which is better, managed Kafka or self-hosted Kafka? So Manjunath, managed Kafka is always better because you don't have to worry about infrastructure handling. But if cost is a consideration, then obviously self-hosted Kafka is better. Now again, like I said, worrying about which technology to use, that is an architect's problem, or not for system design. For system design, you wouldn't be asked these kind of questions that, would you prefer Kafka or this or that? Because most of the companies that you'll be applying to, like Facebook and all these companies might not be using Kafka. They will be having their own queuing and own streaming systems, right? Their own technologies in-house. Okay. How do we get breaks in between? So Animesh is saying, would we get breaks in between? Yes, Animesh, around 9:15 we'll have a 5 minutes break. Okay. Okay, so Dhruv Sharma is saying an out of context question, but is it still necessary for 10 plus years experience person to learn DSA, or should I only focus on system design? So Dhruv, I think will be beneficial